Welcome back to Further Solutions Academy. Further Solutions Academy. Encourage us to share and also subscribe. If you have not subscribed before, press on your subscribe button. We have over 250 videos on this platform. It means you can come here to learn any topic of your choice. Just come and learn. Even though you are expecting a topic to be there and it's not there yet, you can leave a comment below. Just leave a comment below. Don't forget that you can also reach us on this line. With this line, you can call us. With this line, you can WhatsApp us. With this line, you can Telegram is allowed. These are the, Okay, I have a topic for you, which is gas thermometer. Now we have done the one of resistance. We all know what resistance is all about. For we that are doing physics, we're always on the electricity part of it. We have done gas in liquid. Liquid in gas thermometer. And also now I will be working on gas thermometer. Now this gas thermometer, it means purely we are majorly on pressure. Just notice that it's very, very important that I have it at back of that we are working directly on pressure with the proportion with the what? Temperature scale. Now I've told you temperature scale, we have three of them basically, which is Celsius, Fahrenheit, and Kelvin. Make sure you watch our previous video before you watch this video. Now, when you hear of gas is all about pressure, and take note of that information. It's very, very important. Now, when you talk about pressure, what can I say about pressure? We all know what pressure is all about, which I'm planning to say anything. Okay, there is a linear or directly proportion relation between the temperature of a constant volume gas thermometer and its pressure. This is what I was talking about then, that there will always be a proportion between of them, which is gas and now I don't know. Okay, should I? There's no time, but make sure you understand this word very well. Pressure, very, very important, is a key, because pressure and gas, they are friends, so that you can understand this gas very, very well. Now, I have no much to say anyway. As the temperature, now as temperature increase, the pressure of the gas increase. As temperature decrease, the pressure of the gas also decrease. Now, those are the things that you need to know that's about gas and temperature and what and pressure. Just not take note of that information. Now, calculating pressure involves gas, I mean, calculating involving gas thermometer are done in similar way, which is the way we did on the other parts. But this time around, we'll be using the volume, I mean, the formula, the unit of pressure along. It means in a previous video, we are playing around with ohms, but this time around, we'll be playing around with what? Pressure. That is just what is there. Just take note of this information, that as temperature increase, the pressure also increase. As temperature decrease, and the pressure of the gas also decrease. Now, I don't have much to say, but just take note of that information. Now, let me quickly go for examples on this part. An example of this part. Now, I have this part to explain. I mean, let me use this expression to explain this. A constant volume of gas of I have to put G here at the ice point and 400 mmHg at the steam point. What would the temperature be in degree Celsius? In degree Celsius when the gas thermometer records a pressure of 360 mm. HQ. Now, I have this type of question to work on. This time around, I've told you earlier that we'll be playing along with what? Pressure of the gas, which I've told you. Now, solution to this problem. Now, what I will first do is that the first point of this, we are working along with Celsius. We are working along with Celsius, and there will be a big problem if you cannot remember a scale of pressure. I mean of Celsius, which I've told you in our two previous videos that Celsius read from 0 degrees Celsius to 100 degrees Celsius. Make sure you understand those things very well. It means I'll be having the first point pressure, which is a 320 mmHg and 400 mmHg, and the record (360 mmHg). Now, on the gas thermometer is corresponded with the Celsius scale as. Now, it means once it's corresponded to Celsius scale, I'll have it this way, and I'll have another one this way. This will stand for what? The pressure, while the other one will stand for what? The Celsius scale. Now, we have upper and the lower. We have upper and the lower, which I'll be talking about. This will tell me this is upper 400 mmHg. This also will be upper of Celsius is 100 degrees Celsius. Now, also we have 320 mmHg, and this will be 0 degree Celsius, which is that is the point. And also we are talking about 360. 360 will be somewhere here. 360 mm, which something we don't know. Put it theta. Theta will help us. Now, with this, I can take my reading, which I can take. Don't forget that this minus this, 360 minus 320 divided by 400 minus 320, which also theta minus 0 degrees Celsius divided by 100 degrees Celsius minus 0 degrees Celsius. This is MH. Let me put in bracket of MH. Please take note of that. Normally, if you cancel out, which I have with that number, I'll be having 40, and also I'll be having 80. I'll be having 80 equals to theta divided by 100. This will cancel this, here 1, here 2. Now, I'll be having 2 theta equals to 100. If I multiply by 2, my theta will be equals to 50 degrees Celsius. Please make sure you put the unit. Is very, very important. That is all what I want to do. That is what I want to do. And let me quickly put more example so that you can understand this part very well. Now, I have this type of question, which is very straightforward. Okay, a constant volume of, gas thermometer is used to measure the room temperature during an experiment. If the gas pressure at 273 Kelvin is 220 mmHg and 290 mmHg at 273 Kelvin. What is the room temperature if the thermometer records records a pressure of 234 mmHg. Now, if I have this type of problem, the same way, the same pattern, but this one is very straightforward and direct because you are given both sides. You are given both sides, no stress at this point. You know, don't need to stress yourself. It means we have this, we have this, we have this, and also have this. Your problem is basically half solved. Now, with this, I can say that my solution. Now, lower and upper fixed point pressure. (220 mmHg and 290 mmHg. Now, that's what I want to work on, and also, the recorded pressure 240 mmHg. Now, with this, you can finish, just do the corresponding, and you have it and get it right, which I'll be having something like this. Now, we're talking about Kelvin and pressure. Now, it means my upper and my lower are corresponding to this and this. That is what I will work on, which I'll be having 290 here and also having 220 here. Now, talking about the Kelvin scale, which is this is going to be one will be 370 and this is 370. Mistake here. 370. 373 Kelvin and 273 Kelvin. Now, what we read is that we read recorded one is 224. Theta in Kelvin. With this, I'm good to go, which I will do the final and initial, which I've told you earlier that I'll be having 220 minus 223 divided by 290 minus 223 equals to theta minus 2 divided by 3 minus 2. Now, with this, don't forget that the units we are working on Kelvin, 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 and this one is mmH, mmHg, and so on and so forth. Anyway, let me put in brackets. So this will move out this. Now, with this, I can have this minus this. I'll be having 14 divided by 70 equals to theta minus 273 divided by 100, which I have 70 bracket of theta minus 273 equals to 1400. I just cross multiply. Since I have that, I can do whatever I want to do. I can decide to open my bracket minus 70 times this, which is going to be 19,110 equals to 1,400. With this, 70 theta equals to 1,400 plus 19,100, which I have, which is equals to, I'll be having 2,510. Divided by 70 times 70, which I will have this. My theta will have 293. 293. That is what it means. Here is 293. That's what I'm looking for. Now, with this, you can see that temperature is very simple to understand. It's a direct topic on physics. Now, in our next video, which is on our next part of our video, we'll be working on heat capacity. Heat capacity is a very interesting part, and you can watch out for that video. It's very, very interesting. With this knowledge of thermometer temperature, you will understand heat capacity very well. That's very, very important. Don't forget that you are on with Further Solutions Academy. You are on with Further Solutions Academy. You are on with Further Solutions Academy. Further Solutions Academy. I encourage us more to share, and also you to subscribe. You have to subscribe if you have not subscribed before, and leave a comment below if you are expected a topic to be there and it's not there yet. Just leave a comment, or you reach us on this line 234-803-4495-990. With this line, you can call us, you can WhatsApp us, and Telegram is allowed. And also, if you want to make any contribution, we really need your help at this moment. No amount is small. Just help us, With this, you can reach us, and also you can send our account number to you and you help us. Once again, thanks for watching.